everyone and welcome back to Diksha Karnataka YouTube channel. And today is Sunday and I am here as promised with KPL mock test number 7. And if you have attempted the question, I will discuss all the solutions. But if you are still not able to download the question paper, you can join our WhatsApp group. The link is given in the description. Download the question paper and then you can solve along with me. Okay, so if you are already solved it, then let's see how much score you have made, and if you have not yet solved it, then you can solve with me and you can check instantly how much you scored. Okay, so let's start with the questions. First question is energy of a photon of frequency 10 to the power of 16 hertz is. So they have asked you to find the energy of a photon. It's very simple question. Energy of a photon E is equals to h nu, right? So h is 6.6 times 10 to the power of minus 34 joules in the units of joules. Okay, and frequency is 10 to the power of 16 hertz. So just multiply them. Okay, simple as that. So it will be 6.6 times 10 to the power of minus 18, right? So 6.6 times 10 to the power of minus 18 joules. So you have to be careful which one is correct answer. 6.6 into 10 to the power of minus 18 joules. This is not in EV. Be careful. If they ask you to find in EV, then you have to divide it with 1.6 times 10 to the power of minus 19. This is not in EV. This is in joules. Okay. Now, the rest mass of photon is, so rest mass of the photon, so what is the meaning of that? So if the photon is at rest, then what will be its mass? Rest mass of a photon is 0. Okay, rest mass of a photon is 0. The radiation of energy E falls normally on perfectly reflecting surface. Okay, the momentum transfer to the surface is. So what is the thing? So you have a perfectly reflecting surface. Light comes and light goes. Okay, so what is the first of all you have to calculate what is the energy of that. Energy is given E. Okay, now we know that h nu, right? Again we can write this as hc by lambda. So what is the wavelength? Wavelength is hc by E, right? So wavelength is hc by E. Now we know that from de Broglie's principle, if this is the de Broglie wavelength, then in that terms we can write this as h by p, right? So if this is, suppose this is a real matter having some momentum and they are hitting it, okay, so the real momentum will be h by p. So comparing that, we can, comparing these two, we can find the momentum p. So p will be h e divided by hc. Okay, so h is cancelled, so it will be e by c. Now this is for one side. So one side is this. Now after it reflects, okay, after it reflects, so it will be total momentum, change of momentum, p is coming, another p is going, so total change in momentum will be 2p. So total change in momentum will be 2p, that is 2e by c. This is the change in momentum. Okay, so momentum transferred is 2e by c. Right? Why 2e by c? If you remember your first PU chapter, you throw a ball towards the wall, how much momentum is transferred, what is the force, etc. You have solved it. So basically, instead of throwing a ball, you are throwing a light, and that light can still transfer some momentum to the wall. So that is called, this is the momentum transferred by the light. Okay. Now, the stopping potential of a photoelectron emitter is determined to be 4 volts. So what is the stopping potential? V naught. V naught is given as 4 volts. Okay, the maximum velocity of an electron ejected by radiation will be, so maximum velocity they have asked you to find the of the electron, right? So now we know that. Also they have given E by m is equal to 1.8 times 10 to the power of 11 coulomb per kg. Now we know that Kmax is E V naught, right? So stopping potential times the charge of an electron should be equals to its maximum kinetic energy. Now what is maximum kinetic energy? Maximum kinetic energy is mv square. Okay, so here v is the maximum velocity, so let me write it vm, okay, for convenient. Now vm square will be equals to 2e by m v naught. Okay, so these two will go here, and e by m is given as 1.8 times 10 to the power of 11, and v naught is given 4 volts. Simply add these values. Okay, so what will be the answer? It will be if you consider this 1.8 to be almost equals to 2, okay, so then 2 2s are 4, 4 4s are 16, it will be very close to 16 but less than 16, okay, so very close to 16 but less than 16. Now this is Vm square, right? Don't make this like this, okay, let me solve it in a different way. So 2 times, let me take 1 0 out of this 10 to the power 11. So what will happen if I take 1 0 out? So it will be 18, and here I will have 10 to the power of 10. Okay, so 4. Now let me write this 18 as 2 times 9. Okay, times 10 to the power times 4 times 10 to the power of 10. Now it will be easier for us to do the square. Okay, so Vm square will be Vm square is this. So Vm will be square root of everything. Square root of everything means if there are 2 2's, there will be 1 2 only. 9 square root is 3, and 4 square root is 2 times 10 to the power of 10. 10 to the power of 10 square root will be 10 to the power of 5 by 2, right? So it will be 2 3 is a 6, 6 2 is a 12. Now let us check the answers. So in the answer, none of the answers is correct except this one. So what we will do, we will have to adjust one decimal to get the correct answer. Okay, simple as that. So correct answer is option D, right? Now let's move on to the next question. When light of wavelength lambda less than threshold wavelength lambda naught is incident on a metal surface, the emitted electrons. Okay, so they have given you that the wavelength lambda is less than that of threshold wavelength lambda naught. Okay, is incident on a metal surface, the emitted electrons will have kinetic energy that depends on the wavelength of the incident light, will be 0. Will have no kinetic energy, will have the kinetic energy proportional to the intensity of the incident light. Now first of all, this is very tempting to mark this as will be 0. Okay, so it is very tempting to mark this as 0, but remember that it is not in terms of frequency. If the same question was asked in terms of threshold frequency, that frequency nu of less than that threshold frequency nu naught incident on a metal surface, then it would have been 0. Okay, there would have been no emission, but this is given in terms of wavelength lambda. Okay, so we know that K max equals to h nu minus h nu naught. Okay, if nu naught is greater than nu, then there would have been no emission because kinetic energy cannot be negative, right? But fortunately here it is given in terms of wavelength. Now wavelength is inversely proportional to frequency, so you can still have some value. Okay, so hc is common, 1 by lambda minus 1 by lambda naught, right? Now this is possible. Okay, even though lambda is less than lambda naught, okay, 1 by lambda will be greater than 1 by lambda naught, right? So suppose lambda is say 500 and lambda naught is say 600 nanometers. Okay, so then in that case you can still write this as 1 by 500 minus 1 by 600. Any doubt? This will be greater than 1. So as long as it is greater than 1, this formula is valid, right? Now, so here as you can see, lambda naught is a constant. So the kinetic energy, maximum kinetic energy will be proportional to 1 by lambda, right? So we'll have a kinetic energy that depends on the wavelength of the incident light. It depends on the wavelength of the incident light, but how it depends? If they ask you inversely proportional, directly proportional, that also you will be able to answer if you know how to solve this question. Okay. Now remember that kinetic energy is independent of the intensity of the incident radiation. Okay, saturation current only depends on the intensity of the incident radiation, not the kinetic energy. Okay, be careful about that. Now, when the point source of light is 1 meter away from a photoelectric cell, the photoelectric current is found to be I milliampere. If the same source is placed at 3 meters from the same photoelectric cell, the photoelectric current will be. This is very interesting question. Okay, so for now the question is based on photoelectric current. Now what we know about photoelectric current? Photoelectric current depends on the intensity of the incident radiation, right? Now in this case, because current is also mentioned I am mentioning intensity as curvy I. Okay, are you familiar with this I? If no, please mention in the comment below. This is also a I, but some stylish I. So this is intensity. Let me write this as intensity. Intensity is also mentioned as I. Now physicist weird subject where many symbols have similar things. Okay, you cannot pinpoint except modern physics where symbols have very specific meaning. Other than that, there are some common symbols. Okay, so for example this I. Okay, one more example is momentum and dipole moment. Okay, they are also have same symbols, right? So intensity is I. Current is also represented using I. Okay, now let me represent intensity I with this. Now we know that intensity is inversely proportional to the square of the distance. So further the distance is, intensity is decreasing with square, right? So suppose initially the intensity of the light was I1. Okay, the initial distance was 1 meter. So I1 by final distance is 3 meter, right? Final distance is 3 meters. So I1 by I2 equals to D2 square by D1 square. This is the law of inverse proportionality, right? We have already solved this kind of questions. So D2 is 3 meter whole square and D1 is 1, right? So simply put the values. It will be 9 by 1, right? So I2 will be I1 by 9. Okay, inversely proportional. So I2 will be I1 by 9. Now saturation current depends directly on the intensity of light. So we know that suppose the first current is I1. Okay, it is proportional to the intensity I1, right? Similarly I2 will be proportional to I2. So we can write this as I1 by I2 as I1 by I2, as simple as that, right? Now I1 by I2 you have already calculated is equals to 9. So equals to 9, and we are trying to find current I2. We are trying to find current I2. So I2 will be I1 by 9, right? What is I1? Initial current is given as I milliampere. So I1 is I milliampere. So I1 by 9 milliamperes. Okay, so correct answer is I1 by 9. So this is nothing to do directly with current. This is only to do with the intensity. So be careful when such question comes. It is basically a combination of some light as well as radiation and matter. So you have to be careful to answer such questions. Don't mark it as 3i by default because student think, okay, I am guessing the answer, it should be 3i, but you can solve it. It is a easy question. Okay, so next move on. The number of photons of wavelength 600 nanometer emitted per second by an electric bulb of power 60 watt. Take H is equal to 6 times 10 to the power of minus 34 joule per second. So they have asked you to take a round figure for H. Now they have asked you to find the number of photons. So what is the energy of a single photon? Energy of one photon is H nu. Okay, or this can be written as Hc by lambda. Okay, it is given in terms of wavelength, right? Wavelength is 600 nanometers, so Hc by lambda. Now total power of the bulb is 60 watt. total power of the bulb is 60 watt. So now if n number of photons are being emitted, then total energy should be 60 watt in SI unit. If I use everything in SI unit, then I can calculate and I can get this value. Right now let us put the value. We are trying to find this value n. Everything else is given. Hc by lambda equals to 60. Now let us start putting the values one by one. So n we are trying to find equals to 60 lambda divided by Hc, or 60 times 600 nanometers. 600 nanometers means what? 600 times 10 to the power of minus 9. Okay, nanometer is easy. Nanometer 10 to the power of minus 9. So nano minus 9 has some. Now H is 6 times 10 to the power of minus 34, and C is 3 times 10 to the power of 8. Okay, speed of light. Now you can cancel this 6 with this 10. Okay, and now we have to simplify it. Okay, so 3 will be cancelled, it will be 200. Okay, so it will be 200. Okay, 200, and there is one more 0, 2000. Now I have to calculate the 10 to the powers carefully. Minus 9 plus 34 minus 8. Okay, so we have just switch the positions, and whatever was negative become positive, whatever was positive become negative. So it is minus 9 minus 8 minus 17, minus 17 plus 34 is plus 17, right? So it will be 2000 times 10 to the power of 17, or 2 times 10 to the power of 20. Okay, so 2 times 10 to the power of 20 is the correct answer. If you get any other answer, or if you make any mistakes, please let me know in the comment below that what is your doubt, right? Now let's move on to the next question. The work function for aluminium is 4.0 electron volts. The cutoff wavelength for photoelectric effect for aluminium is. So what is that? The work function for aluminium is 4.0 electron volt. So phi naught is 4 electron volt. Okay, the cutoff wavelength for photoelectric effect. So we know that phi naught is h nu naught, right? Same equation. So h nu naught, so hc by lambda 0, right? These are all known equations, we already studied that, but here everything is in SI unit. We have to convert it into nanometer. Right now, one important thing is hc is equal to 1240. This is an important value that you should remember. Okay, when you are writing this in terms of EV nanometer. Okay, you can put these values and you can convert it into nanometer and EV, then you will get this value. So what will happen? You will get your answer exactly the unit that you are looking for. Okay, so this is one of the very easy way to solve this question. This is the shortcut. This is the shortcut that you have to remember. So phi naught is hc by lambda 0. So hc is 1240 by lambda naught equals to 4 EV. Okay, so lambda naught is 1240 divided by 4. So it is 3 4s are 12. Okay, 4 1s are 4, 0. So 310 nanometer is the correct wavelength. Okay, 310 is the correct wavelength. Now let's move on. So simple question. Okay, if you know this, it's a simple question. If you don't know this, if you start putting the values of H, then C, then EV, then it will be a very long answer. It will be a very long question and it will take a lot of time. But if you know this shortcut, you can solve it using one line only. A photon of energy 10 electron volt is incident on a metal surface of threshold frequency 1.6 times 10 to the power of 15 Hz. Okay, and they have asked you to find the kinetic energy of the photoelectron in EV. Okay, so first of all, what is the energy? Incident energy is 10 electron volts. Okay, so we know that K max is equal to energy of the incident photon, that is h nu minus phi naught, okay, or h nu minus h nu naught, okay. So here h nu itself is given as 10 electron volt, right? H nu itself is given as 10 electron volt, and what we have to do, only thing that you have to do, you have to calculate h nu naught. Nu naught is given, this is nu naught, okay, nu naught is given. Only thing that we have to do, you have to convert this h nu naught into EV, that's it. Otherwise this is a very simple problem, right? So what we have to do, first we have to write h nu naught. Here there is no shortcut, you have to do it real way, because if it was given in terms of wavelength and it was given in nanometers, then you could have applied hc by lambda shortcut here, but here there is no other shortcut. So in fact they have given the values as well. So 6 times 10 to the power of is minus 34, okay, minus 34. I hope that you have understood that 6 times 10 to the minus 34, and Hertz is given 1.6 times 10 to the power of plus 15, okay. This is in joules. Now how can we convert it into electron volt? To convert it into electron volt, we have to divide it by 1.6 times 10 to the power of minus 19. Simple, okay, as simple as that. So this will cancel and it will go up. So I hope you have understood basic things. Plus 15 plus 19. Plus 15 and plus 19 is 34. Plus 34 minus 34 is 0. So 10 to the power of 0, 10 to the, any number to the power 0 is 1. So it will be 6 eV. Okay. So it is nothing but 6 eV. So maximum kinetic energy is 4 eV. Okay. So correct answer is 4. Now the slope of frequency of incident light versus stopping potential for a given surface will be h is Planck's constant and E is charge of an electron. So they have asked you to find the slope of frequency of incident light versus stopping potential for a given surface. Okay. So we know that maximum kinetic energy is given by h nu minus h nu naught. Okay. Now they have asked you to, when what you are plotting stopping potential. Now K max, if the stopping potential is V naught, then K max can be written as E V naught, charge of an electron, and V naught is the stopping potential. So let me write it here. So E V naught equals to h nu minus h nu naught. Okay. So V naught equals to h by E nu minus h nu naught by E. Now if you consider this is the y equals to mx plus c. So if you compare this with our known equation, here V naught is y, nu is x. Okay, so comparing that, we can write the slope to be m equals to h by E. Okay, and the intersection is minus h nu naught by E. So both you can find if you know how to write this equation. So it is h by E. Correct answer is option A. Okay. A radio station is transmitting waves of wavelength 300 meters. Radiation capacity of the transmitter is 10 kilowatt. The number of photons which are emitted per unit time is. This is also similar question. Okay, only this time they have given it is in terms of wavelength. So we know that hc by lambda times n, similar questions, right, equals to the energy transmitted. So n we are trying to find, so n equals to E lambda divided by hc. Okay. Now what is E? E is 10 kilowatt. Kilo means 10 to the power of 3. Lambda is 300 meters. It is already given in meters, so we don't need to convert it to anything else. H is 6.6 times 10 to the power of minus 34. Okay. And C is 3 times 10 to the power of 8. Okay. Now let us think that 100. Okay. So it will be 1000 times 10 to the power of 3 divided by 6.6 times 10 to the power of minus 34 plus 8. So, it will be 1 by 6.6 times 10 to the power of 3. This is another 3. So, 6 plus 34 minus 8. So, it will be 10 to the power 1 by 6.6 times 10 to the power of 32. Okay. So, this is the answer. Now, here we have to be careful and we have to choose the 10 to the power value correctly. Okay. Now, if you take this value approximately to be 6 and if you take out one of the tens from here, okay, then you will get 10 by 6 times 10 to the power of 31. Okay, so they have taken the approximation value of h to be 6 times 10 to the power of minus 34. That's it. Now, if you do that, then you will get this will be 1.5, right? So, 1.5 times 10 to the power of 31. So, correct answer is option B. Okay. Now, mention that in the comment below if you have corrected this question or not. Yes, mention no. Sodium and copper have work functions 2.3 electron volts and 4.5 electron volts respectively. Then the ratio of the threshold wavelength is nearest to. Very interesting question. Okay, they have given the work functions. So, work functions for sodium. Okay, work function for sodium is given 2.3 and work function for copper is given 4.5. Okay. Now, work function is nothing but h nu naught. So, I am just not writing any naught, I am just writing the name of the substance. Okay. 4.5, 2.3. Now, they have asked you to threshold wavelength. Be careful, right? So, h c by lambda Na is equal to 2.3 and h c by lambda cu equals to 4.5. Right. Now, they have asked you to then the ratio of their threshold wavelength. So, first will come sodium, next will come copper. Okay. So, what we will do, we will divide this by this. Okay. So, Hc by lambda copper divided by Hc by lambda sodium. Why so? Because as you can see, this is inversely proportional. So, whichever is at last will go up. So, 4.5 divided by 2.3. Okay, now if this number is 4.6, then we could have cancelled this and we will get 2 by 1, right? So, this is the nearest integer value. Now, you can write this side as lambda Na divided by lambda Cu, right? This will go up, HC will cancel, it will be 2 by 1. So, correct answer is 2:1, okay? Not 1:2, it is 2:1. You have to be careful about the order. You have to, especially if they ask you find the ratio, what will be the ratio, in that case you have to be careful what is the order given in the question and what order you are calculating, because definitely they will give you a reverse order as well. So, even if you calculate it correctly but you have found the reverse order, okay, even though your answer is correct, you will not get the correct answer. So, you have to read that question carefully. Now, which one of the following graphs represents the variation of maximum kinetic energy Ek of the emitted electrons with the frequency of photoelectric effect? So, as we know, correct answer is this. Okay, so frequency versus kinetic energy is this straight line. Only thing is interception is negative and slope is, we can also know the slope h by e, right? We have solved in few questions back. So, correct answer is option D. Now, let us move on. When a piece of metal is illuminated by a monochromatic light of wavelength lambda, the stopping potential is 3V. Okay. When the same surface is illuminated by a light of wavelength 2 lambda, the stopping potential becomes V. Okay. The value of threshold wavelength of the photoelectric effect. Very interesting question. So, we know that threshold frequency, in terms of threshold frequency, Einstein's equation becomes h nu minus h nu naught. Okay. So and then we can write this as hc by lambda minus hc by lambda naught, right? So these are already we have learned, we are already solving using this relationship. Now in the first case, also let me rewrite this equation for particularly this question. I will simplify this side. So I will write 1 by lambda minus 1 by lambda naught. What I have done, I have taken the hc common and I have divided it on the other side for this question only, okay? So what we will do, they have given initially the wavelength was lambda and the stopping potential is 3V. So 1 by lambda case 1 minus 1 by lambda naught equals to E times 3V by hc, okay? And the second case, when the wavelength becomes 2 lambda, okay, minus 1 by lambda naught equals to E times the stopping potential is now V by hc, okay? Now there are 2-3 ways to solve this question. The easiest way is to see, here we have EV by hc, here we have 3 EV by hc, okay? If you just simply take this 3 out and write it outside, then you will see this and this term are same. So what we will do, there is in the options given, there is no EV, there is no V, there is no H, no C, nothing is there, right? So we have to substitute this EV by HC here, okay? Otherwise what you can do, you can just divide them and find the ratio, that is also fine. But since this is easy, I am doing this way. So I am using this equation, okay? 1 by lambda minus 1 by lambda naught equals to 3 times this value. Now use this value here, 1 by 2 lambda minus 1 by lambda naught, okay? Now let us solve this equation, okay? So we will not do a multiplication here right now. We will try to segregate lambdas and lambda naughts one by one. So 1 by lambda, okay, if I take this on this side, what will happen? If I take this on this side, it will become minus 3 by 2 lambda equals to, now this 3 lambda naught, 3 by lambda naught, negative will be on this side. So minus 3 by lambda naught will be this side, and this 1 by lambda naught will go on the other side and it will become positive. So plus 1 by lambda naught. Okay, don't worry if you are getting in negative values, it will be cancelled and you will get a good value. So 2 lambda, now 2 lambda, so it will become 2 lambda minus 3 lambda, here it will become minus 2 by lambda naught, okay? 3 by lambda naught minus 1 by lambda naught is minus 3 by lambda naught, okay? So now let's solve it again. So we will get minus, sorry, one mistake I made, there won't be any lambdas here, okay? So yes, because it is lambda is common, right? So minus 1 by lambda is equal to minus 2 by lambda naught. Now do the cross multiplication, minus minus cancels. So lambda naught equals to 2 lambda. So lambda naught is 2 lambda. Sorry, there is another 2 here. So the 2 here, 2 minus 3 is minus 1, but 2 still here. So lambda naught will be 4 lambda, obviously. Lambda naught will be 4 lambda, right? Now let's move on. So what is the correct answer? Correct answer is option D. Now, two identical photocathodes receive light of frequency F1 and F2 if the velocities of the photoelectrons of mass m coming out are respectively V1 and V2, then, okay, very interesting question. So we know that K max equals to h nu minus phi naught, okay, or what they have said in this case, they have mentioned that K max 1 is equal to h f1 minus phi naught, same material, right? And for K max 2 equals to h f2 minus phi naught, right? So now again, what we know, Kmax is what? Kmax is kinetic energy, maximum kinetic energy, and what is the formula for kinetic energy? mv square, half mv square. So it will be half m v1 square, and it will be half m v2 square. Now just subtract them, okay? So half m will be common, v1 square minus v2 square equals to phi naught will cancel. We are doing the negative minus, right? So it will minus, it will be plus, they will cancel. So h f1 minus f2, right? So v1 square minus v2 square equals to 2h by m f1 minus f2. Is it difficult question? Tell me, did you find it difficult? Were you able to answer this question? So v1 square minus v2 square is equal to 2h by m f1 minus f2, not the square root 1, okay? Easy question, okay? Now let's move on. Which of the following figure represents the variation of particles momentum and associated de Broglie wavelength? Very interesting question. So we know that wavelength is h by p, right? Wavelength of light is h by p. Now this is the momentum. They have asked you, if you plot momentum and lambda one after another, then what will be the graph? Now if you see this graph, what we can see that lambda is inversely proportional to the momentum p. Now if this anything else you get reminded of, okay? If you remember that p proportional to 1 by v, okay? Ideal gas. How was the equation? PV graph, PV diagram. It was like this, right? It was called rectangular hyperbola. Rectangular hyperbola. PV diagram is rectangular hyperbola, right? Also you should remember one more thing. If you find two coordinates x and y, and then if you see x and y is constant, then that graph is called rectangular hyperbola. Now in this case, lambda is proportional to hp, or lambda is equals to h by p. So you can say that lambda p equals to h, right? H is a constant, Planck's constant. Lambda is along x axis, so it is x. P is along y axis, so this is y. So this follows, or this is obeys this equation. So from here you can say that this will be rectangular hyperbola. So this will be the correct answer, okay? Only positive hyperbola. There is a negative hyperbola as well, but that is outside scope because lambda is only positive, wavelength cannot be negative. So this is not possible in case of PV diagram as well, right? Pressure cannot be negative, so minimum possible value is 0, so pressure cannot be negative. So the only positive side of the hyperbola we are using. Now matter waves are, very interesting question, easy question. Elastic waves, no. Mechanical waves, definitely no. Electronic waves, I don't know what is the meaning of electronic waves, but waves which have mathematical existence with physical significance, right? So it has a mathematical existence. For example, I have a mathematically possibly a wave, okay, but I am not a wave. I may have the physical significance of this, but for an electron they will definitely have a physical significance of this waveform. So that's why it is a mathematically possible and it has a physical significance, right? Now question number 18, de Broglie wavelength of neutron is at is lambda at 927 degrees Celsius. What will be its wavelength at 27 degrees Celsius? Now for to answer this question, what you have to remember is that VRMS, okay, neutron is like a gas, right? We have learned that neutron individual particles are behaving as a gas, right? We learned that electron gas. Similarly, if you are considering a single neutron, you can consider it to be a neutron gas, and it is observed in space, okay, where a lot of individual particles can exist. So there it is considered to be a gas, and in case of gas, the VRMS is I think the expression is 3RT by M, right? 3RT by M. So VRMS is inversely directly proportional to the absolute temperature, right? So Vrms is absolute, directly proportional to the absolute temperature. Now what is momentum? Momentum is nothing but m times Vrms. So momentum is also proportional to the absolute temperature. If you remember that for any gas particles, for any neutron or electron or anything else, you should remember that the momentum is directly proportional to the absolute temperature. This is one of the thing that we are going to use here. Now what is the absolute temperature for 927? So T1 is 927 plus 273, right? We have to add that, so it will be 1200 K. And T2 is 27 plus 273. Don't forget to convert them into absolute temperatures. If you don't convert it into absolute temperatures, your effort, your everything will be gone. And I think after seeing these values, you definitely know that there will be some relationship with absolute temperatures. And we know that lambda is h by p. So lambda 1 will be h by p1, and lambda 1 itself is given, I think, is lambda, right? So lambda 1 itself is given lambda, so I am just writing lambda for first value. Second value I am writing lambda 2 will be equals to h by p2. Now divide them. Lambda by lambda 2 equals to p2 by p1. Now p is directly proportional to square root of temperature, except everything is constant, so they will cancel and we will get T2 by T1. So what is T2? T2 is 300 and T1 is 1200. Cancel, 3 12s of 4s of 12, so it is 1 by 2. Okay, so 1 by 2. So we are trying to find lambda 2. So lambda 2 will be 2 lambda. So lambda 2 will be 2 lambda. So 2 lambda. Correct answer is 2 lambda. Right? Interesting question, a new type of questions. I hope you have not faced this kind of question before, but it might come because this formula is still there in your syllabus. Right? For photoelectric emission from certain metal, the cutoff frequency is nu. If the radiation frequency 2 nu impinges on the metal plate, then the maximum possible velocity of the emitted electron will be. So cutoff frequency is given nu, okay, and incident frequency is 2 nu, right? So what do we know that? And they have asked you to find the maximum velocity. So K max is h 2 nu minus h nu. Okay, so nu naught is nu and nu is 2 nu. Okay, so same formula, we have directly used the value so that you don't get confused. Now K max is half mv square equals to 2h nu minus h nu equals to h nu, right? 2 minus 1 is 1, so V will be equals to 2h nu by m square root, right? So 2h nu by m of square root. Simple question. Okay, I hope you have not had any trouble with solving this question. The de Broglie wavelength of an electron in the first Bohr orbit. Now we are mixing de Broglie wavelength and atoms. Right, we have I told you that we are going to solve these two chapters in this KPL. I hope you have prepared well. Equal, the de Broglie wavelength of an electron in the first Bohr orbit is equal to the half the circumstance of the first orbit, equal to 1/4 circumstance of the first orbit, equal to the circumference of the first orbit, equal to the twice the circumference. Now we know that 2 pi Rn equals to n lambda. Okay, so for first orbit definitely 2 pi R1 equals to 1 lambda. So only lambda. 1 times lambda means what? 1 times lambda means lambda. So this is lambda. 2 pi R1 equals to lambda, right? So equal to the circumference of the first orbit, right? Now let's move on. In hydrogen atom, electron excites from ground state to higher energy state and its orbital velocity is reduced to 1/3 of its initial value. The radius of the orbit in the ground state is r. Okay, the radius of the orbit in that higher energy state. So what is the given here? So the orbital velocity is reduced to 1/3. Now we know that orbital velocity is proportional to 1 by n. Orbital velocity is proportional to 1 by n. Now at ground state, suppose orbital let's see, v is equal to some constant, proportionality constant by n. Okay, we know that if it is proportional we can remove that. Now in ground state we can write v1 equals to k by 1, that is k, and at some higher energy state, suppose at Vn, it will be k by n, and that is equals to 1/3 v. Right, now what is v? V is k, so k by n is equal to 1/3 k, k cancels, so we can write n equals to 3. Right, so this is basically very simple, that orbital velocity is inversely proportional to the quantum number. So from there we have to first calculate the quantum number, 1/3. So if you know that, you can directly write 3 is the quantum number. Now they have asked you to find the radius of the orbit of the ground state is r, then radius of the orbit of the higher energy state. So higher energy state radius is directly proportional to n square, and in terms of ground state we can write this as n square r. Right, this is also we have learned. So n is given as 3, so 3 square r, so it will be 9r. Okay, 9r will be the correct answer. Simple. So you should remember these two very important things. Okay, velocity is inversely proportional to the principal quantum number, and radius is directly proportional to the square of the principal quantum number. Right, now the hydrogen atoms are excited to the stationary state designed by the principal quantum number equals to 3. It is not designed, it will be designated by. Okay, designated by the principal quantum number equals to 3. The maximum number of spectral lines emitted by the hydrogen atom as explained from Bohr's theory. So we have n equals to 3. Okay, then n equals to 2, and ground state n equals to 1. Now you have excited one electron to n equals to 3 state. Okay, now this electron, when it is coming back to ground state, how many spectral lines it can emit? How many? First of all, it can emit one by jumping from n is equal to 3 to n is equal to 2. Secondly, it can jump from n is equal to 3 to n is equal to 1. Okay, secondly, once it reaches n is equal to 2, one frequency is emitted, from here to here another frequency is emitted. Okay, so we get 1, this 2 and this 3. Okay, this one already considered. So 3 lines can be emitted by the electron while jumping from n is equal to 3 to n is equal to 1. The question is easy for n is equal to 3 level. Okay, but if you go to n is equal to 4 level, okay, then it will be little bit difficult. There will be 6 or 7 lines you can get. Okay, so it is not directly equals to the number of line, number of quantum number. Okay, be careful about that. Okay, now next question. In Bohr's model of hydrogen atom, let Pe represents the potential energy and Te the total energy. In going to higher level, what will happen? So what they have said, that Pe is potential energy and Te is total energy. Now we know that total energy, relationship between potential energy and total energy is Pe equals to 2Te. Okay, including the sign. Right, if you remember, we have solved one question, there we have answered this, Pe is equal to 2Te. Also kinetic energy, if you consider kinetic energy is modulus of total energy. Right, these are the things that you have to remember. Okay, these 3 equations. Now potential energy is equal to 2 times total energy. Now as you go in the higher level, what happens to the total energy? Total energy becomes less negative, right? Ground state total energy is minus 13.6 eV. Okay, as soon as you move to the next level, it becomes 1/4 of that, that is 3.4 eV, minus 3.4 eV. Okay, so that is at n is equal to 2. Now you go to level 3, it becomes 1.5, right? So as you are going to higher level, the negative sign and the number is decreasing, but the negative, there is a negative sign, so less negative. Even if something is less negative, that means it is increasing, right? Something has to be added to that, then only it can become less negative, right? So as you are going to higher energy level, total energy and potential energy both are becoming less negative, so they are increasing. So potential energy increases and total energy increases, both are increasing, right? Only kinetic energy is decreasing. Now what is the energy of the electron revolving in third orbit expressed in electron volt? So we know that En equals to minus 13.6 divided by n square. For third orbit E3, minus 13.6 divided by 3 square, that is minus 13.6 by 9, and this will become 1.51 eV. You can calculate that, I already did it. Okay, 9 ones are 9, then decimal, okay, 9 fives are almost there will be 46, 9 fives are 45, and there will be, you can do one more step. Okay, so correct answer is minus 1.51 electron volt. Okay, now question number 25. The energy of an electron in an excited state of hydrogen atom is minus 3.4 electron volt. The angular momentum of the electron in this state is. So first of all, I already told you what is the quantum number for this. So energy is given as, see these things, if you know, if you have practiced such questions, it will be easier for you, because we are currently solving these questions, it will be easier for you. But if you don't know, I am using a little bit longer method so that you don't forget the method. So En is minus 13.6 by n square, right? Now here it is 3.4, minus 3.4, obviously minus 13.6 by n square. So n square is 13.6 divided by 3.4. So if you cancel, you will get 4. So n equals to 2. So n equals to 2 means, if you remember all the energy levels at least up to 4 or 5 levels for hydrogen atom, it will be very helpful for you. At least 4, level 4, up to level 4, 0.9, point something, 7.8, whatever is value. If you remember up to level 4, it will be very useful for you to solve this question. So as soon as you can see, okay, 3.4 eV, that means it is in n equals to 2. Right? Now, what is the angular momentum? Angular momentum is nh by 2 pi. So you have to calculate this thing. Okay, this is, there is no shortcut. N is 2, h is 6.6 times 10 to the power of minus 34, and 2 pi is 2 times 6, 3.14, right? 3.14. Now 3.14 is 6.28. 6.28 and 6.6 are very close, so approximately we can cancel that and we can write this as 2 times 10 to the power of minus 34. Now let's see what all are the given options. So in the given options, only the closed option is 2.11. So 2.11 is the correct option, because everything has 10 to the power values are same. 10 to the power minus 34 is same. Minus 34, minus 34, minus 34, minus 34. Okay, so this is the correct answer. Okay, now next question. The figure shows the energy level of certain atom. Okay, when the electron D exists from 3e to E. Okay, so when electron jumps from 3e to E, one electron jumps from 3e to E, and what they have said, an electromagnetic wave of the wavelength lambda is emitted. So the wavelength emitted is lambda. Okay, what is the wavelength of the electromagnetic wave emitted when the electron D excites from not de-excites from 5e by 3 to e. So when an electron jumps from here to here, okay, what is the wavelength now? That is the question, right? So very interesting question. So what we know? We know that E initial minus E final. Initial was first case 3e minus final is E equals to h nu, right? The energy of the photon emitted. So this is equals to hc by lambda, right? So 2e equals to hc by lambda, or lambda equals to hc by 2e. Okay, so we have found the first part. Now second part is, it is jumping from 5 by 3 to e. So now if the 5 by 3 is the 5 by 3 is the first stage and last is final is e, that should be equals to hc by lambda dash. Okay, hc by lambda dash, I am directly writing it, I am not using h nu anymore. So from here it will be 2/3 of e equals to hc by lambda dash, right? Now cross multiply, you will get lambda dash equals to hc by 2e times 3. Okay, this 3 will go up, 2e will come down. So hc by 2e, if you see hc by 2e is lambda. So what we have to do, we have to replace it with lambda. So it will be 3 lambda. Okay, so lambda dash is 3 lambda. So correct answer is 3 lambda. Interesting question. I hope you are able to solve with this kind of question. This is not straightforward questions, but not very difficult question. Mathematically solvable and interesting. The period of revolution of an electron in nth orbit of hydrogen atom is proportional. So period of revolution, I solved it multiple times. Period of revolution is directly proportional to n cube, and frequency of revolution is inversely proportional to n cube. Okay, so correct answer is option A, right? Now total energy of electron in an excited state of hydrogen atom is minus 3.4 electron volt, the kinetic and potential energy of the electron of the state. So we already used this formula that kinetic energy is modulus of total energy, that is 3.4 eV in this case, right? And potential energy is twice of energy with sign, so it will be 2 times minus 3.4, that is minus 6.8 eV. Okay, so kinetic energy is minus 3. Not minus, kinetic energy cannot be negative, we should be careful, kinetic energy cannot be negative. So K is 3.4 eV and U is minus 6.8 eV. Okay, so correct answer is option B. Now the scientist who is credited with the discovery of nucleus, Rutherford, not Niels Bohr, Rutherford is the correct answer. The ratio of area of first excited state to the ground state of orbit of hydrogen atom is. Okay, so they have asked you to find the ratio of first excited state to the ground state. Very careful. So first excited state is n equals to 2. So area 2 by area 1. Okay, area 2 by area 1 equals to 2 pi r2 square, pi r square, right? Area is area of a circle, circle's area is pi r square, so pi r2 square divided by pi r1 square, right? Also we know that radius is proportional to n square. Okay, more number, higher number of the orbit, more is the radius obviously, so pi cancels, so it will be n2 means n equals to 2, that is 2 square, right, whole square. So r2 proportional to 2 square, so instead of r2 we have put 2 square and there was a square of its own, and ground state is always easy. Whatever is for ground state, it will be always 1, right? So it will be 4 whole square, that is 16. So 16 by 1. So the ratio is 16:1. 16:1. Now you, as I said, in case of ratio related problems, you have to be careful about the order. They have said that's why I marked it first excited state to the ground state. First excited state to the ground state is 16:1, and if they ask you opposite, then it will be 1:16. Okay, so now we have completed this KPL, and don't forget to mention how much you scored in today's session, and I will be back with a new chapter tomorrow, that is Monday. Till then, tata, bye bye.